Hi guys, welcome to my new video for MSc Mathematics. So in this video we will learn what is cyclic group, what are cosets, what is Lagrange's theorem, what is normal groups, and what is solvable group. And after this video, whatever video I will upload related to group theory, all will be question answers which often come in university examinations. In my previous videos related to group theory, I have given you the notes for basic things of group theory, which is very much required to understand the question answers, which often come in university examination, which I will be uploading in my later videos. And you can consider this is the last video regarding the notes. Okay, this is the videos what will be uploading after what I will be uploading after this video. All will be regarding question answers that often come in university examination. Why I have given these videos, what I have given these notes, because to understand the university question answers you have to know these basic things, otherwise you will not understand the university question answers. Okay, so that is why I uploaded it. Okay, so if you have not watched my previous videos, please watch those videos. Okay, and to get the update, please subscribe my channel. Okay, so let's start. What is cyclic group? If all elements of a group can be achieved from a single element of a group, then the group is called cyclic. That is, every element of group G where A belongs to G is such that AM equal to A binary operation A till M, and the group will be like that. That G will be the set G will be like that, a square till a to the power m, and asterisk, asterisk is the binary operation here. Okay, here A is called the generator of the group. Now example. Now example. Let for example we can consider, let G be a group with members 1, -1, I and minus I, and with multiplication as binary operation. Then for this group I is the generator, because I to the power 1 equal to I square equal to -1, I cube equal to minus I, and I to the power 4 equal to 1. Okay, so G can be written as I to the power 4, I cube, I square, and I. Okay, so member of the group G can be written as I to the power 4, I cube, I square, and I. Order of this group is 4, as the number of the elements of this group is 4. Okay, I have explained it in my previous videos as what is order of the group. Okay, now here the order of the generator I is 4. Why the order of the generator I is 4? Because I to the power 4 actually producing the identity element. So if the order of the generator which produce the identity element is the order of the group, as well as the order of the generator. Okay, if the group is finite. So this is the conclusion, that order of a cyclic group is equal to the order of generator of the group if the group is finite. Okay, next properties of the cyclic group. So what is the first property? If cyclic group is finite, then order of the group is the order of the generator of the group, that I have explained you. In a finite cyclic group, every element can be found as x equal to k, where k is any integer and a is the generator. Okay, now property 3. In a cyclic group G, if A belongs to G and A is the generator, then A inverse is also a generator. So if you just consider this part, you can see, if you just replace the I by I to the minus I here, if you just replace I by minus I, because here minus I is the inverse of I. Okay, you will get the same thing. So that means that if you consider I minus I, it will also give you I to the power 4, I cube, I square, and I as the elements of the G. Okay, so that means if I is the generator, then its inverse minus I is also a generator of the cyclic group. Okay, now point 4. For a finite cyclic group of order n, where A belongs to G and a to the power n equal to e, that is the identity element, then a to the power p is generator of group G and p is co-prime to n. Okay, what is co-prime? Co-prime means that for p and n there should not be any common factor. Okay, now the point 5 is a very important as far as university examination is concerned. So I will give you the proof in the question answer part. Okay, so for now you just know understand the property. Okay, that every cyclic group is abelian. This is a question often, this proof always often come in university examination, that prove that every cyclic group is abelian. Okay, now 5 now point 6, if function f g to g dash is isomorphism, then if a belongs to G and generator of G then if a belongs to G dash will be the generator of G dash and order of A will be equal to order of f a. Okay, function of A. Now what is coset? Why coset is required? Because if you don't understand what is coset, you will not understand Lagrange's theorem. Okay, so I am giving the definition of cosets. Okay, I have already in my videos for MSc Mathematics books, I have already shown you what are the books to be considered as test books. Okay, so after watching my videos, please go through your test book so that the basic things are clear to you, like what is isomorphism, what is coset. Okay, those are elaborately explained in the test books. Okay, so you can go through those in your test book. After watching my video, if you go through your test books, I think you will understand whatever written in your test books. Okay, and that is very much required to understand the question answers. Okay, so now what is coset? What is the definition of cosets? A coset of a subgroup H of a group G is a subset of G obtained by multiplying H with elements of G from left or right. Okay, I think I am sure that you are taking the screenshot of the each part what I am showing, because every time I have explained you, please take the screenshot of the pages, attach them in sequence. That will become very good note for you. Okay, next Lagrange's theorem. Order of a subgroup of a finite group is divisor of order of the group. Okay, what does that mean? Let us suppose G asterisk be a group of order n. G asterisk means here asterisk is the binary operation. Okay, so you know I have explained what is binary operation in my previous video. So please watch my previous videos before watching these videos or watching the question answer videos, so that you can understand the basics thing. So that you have the insight of basic things which are required to understand the question answer. Okay. So what Lagrange's theorem says? Lagrange's theorem says that order of a subgroup of a finite group is a division of order of the group. Okay. So let G asterisk be a group of order n and H asterisk be a group of order m. Then we should have n equal by m equal to lambda. Because why we will have n by m equal to lambda? Because if the order of a subgroup of a finite group is the divisor of order of the group, then we should have, if the order of the group is n and the order of the subgroup is m, we should have some common factor in n and m. Then we can consider let lambda be the common factor among n and m. Then what if we prove that n equal to m lambda, then this theory will be proved. This theorem will be proved. Correct? Now prove. Let Hm belongs to H such that H equal to H1, H2, H3 till n, and An belongs to G such that G equal to A1, A2, A3 till n. Okay, then A1H equal to, what will be the A1H? Because this is the coset. Okay, this is the coset. You can say right coset, left coset. I have explained what is right. It can be multiplied from the right side. When you are multiplying it from right side, it calls right coset. When you are multiplying from left side, then it is called left coset. Okay, so we are multiplying A1 to H from right side here. Okay, so what are the cosets here? So cosets are like A1 H1, A2 H2, A3 H3 till A2 M. So these will be the member of A1H. Correct? Now let us suppose A1 binary operation H1 equal to A2 binary A1 binary operation H2. Okay, this is an assumption. Okay, this is a supposition. Okay, so if A1 binary operation H1 equal to A1 binary operation H2, by left cancellation method, what we will get? H1 H2, but H1 cannot be equals to H2 since elements of set cannot be the same. Elements of set cannot be same. Correct? So elements of H are all H are different. So elements of H are different. A1H, we can write AH. We can say that AH. Okay. If we can say AH. Okay. So AH. So elements of AH are different. So all elements are distinct. All elements are different. Now, how if we generate A1H, how will look how does it look like? It look like a first we have to do A1H. First we have to multiply A1 by H. Then it will give us A1H, H2H till A1 H1. And let us suppose lambda be the total number of cosets here. These are the cosets, and let lambda be the total number of cosets here. For A2H, we will get the same thing like A2H, A2H1, A2H2 till A2HM, and let lambda be the cosets of total number of cosets. And for A1H, we will get the same thing like A1H1, A1H2 till A1HM, and let lambda be the total number of cosets. So we can say like that A1, A2, N belongs to G there, and H1, H2, H3 belongs to G, and H is the subset of G because H is a subgroup of G. Okay, therefore H belongs to G. Therefore H belongs to G. Like these all belongs to G. Therefore we can write like this, that G equals to A1H, A2H, union A2H, A1H, union A2H, dot, that means till ANH, because if all of this belongs to G, then that means that if we do the union of all of these, that will be the member of G. That will be the member of G. Correct? That will be the member of G. So that will be the member of G. That will be the member of G. So now total number of cosets is lambda, and order of H is same. So total number of elements in AH is lambda m. Okay, since we know that from set theory that n A union B equal to n A plus n B minus n A intersection B. Okay, now since order of G equal to n, therefore H has n number of elements, that is n equal to lambda m. Okay, where lambda is the number of left or right cosets. Okay, note, this is a note. This is the converse theorem. The converse of this theorem is not true. That is, if n by m equal to lambda, then m may not be order of any subgroup of the group of order n. Correct? Now, application of Lagrange's theorem. So, what is the first application of the Lagrange's theorem? That is, let G asterisk is a finite group. That is, the binary operation asterisk is a finite group, and order of G is n, and P be a number which does not divide m. Then G will not have any subgroup of order P. Okay. Now, point 2. Let P is a prime number and let G asterisk be a group, and order of G equal to P, then group G asterisk will be a cyclic group. Okay, these are the very important things. Proofs are often asked in university examination. So in the question answer part, I will be uploading the proofs. Okay, proofs. Next, I'm just. For point 2, I have already given you the proof. You can check that, check. This is the proof. It often asks in university examination. I will give you much more things in question answer part now, but these are the basic things, basic proofs you need to know. Oh, okay. So that is why I have included in this video. So let G asterisk has a cyclic group, cyclic subgroup H asterisk of order M. Okay. Then H can be written like this, that A square, A cube, dot M, A to the power M equal to E, identity element. Okay. Then M should divide P, but P is prime. Then M should divide P, but P is prime as per our first property. Okay, as per the first property. Then P equal to M. Then if P equal to M, then H equal to G. And we know that H will be the trivial subgroup of G. Correct? The proof is done here. This third. Let G asterisk be a group, and N be the order of the group. Okay, and A belongs to G, and OA equal to M. Okay, and OA equal to M. Order of OA equal to M. That is the order of the generator equal to M. Then if e to the power m equal to m, then m is the divisor of n. M is the divisor of n. It's a very easy, it's a simple proof, that proof like h equal to a square, a cube, e to the power m, because that has been given that has been given. Okay. Since A belongs to G, therefore A asterisk A belongs to G. Okay, since A belongs to G, therefore A asterisk A belongs to G. This is the property of group. Now H is a cyclic group of order M. Therefore, M is divisor of N by Lagrange's theorem. Okay. Now, what is normal subgroup? What is normal subgroup? Okay. Let G asterisk be a group and H asterisk be a subgroup of G, and let X belongs to G. Then, if X binary operation H equal to left coset of H in G, and H binary operation X equal to right coset of H in G, okay, are equal in G, are equal for all X belongs to G, then H is called normal subgroup. That is XH equal to HX for all X belongs to G. Or we can write like this, that if X H inverse X X inverse belongs to H, then H is called normal subgroup. Okay, we know that all subgroups, we know that all subgroups have we know that all groups have two, at least have two subgroups. We have two subgroups, at least have two subgroups. The group itself, in my group theory, in the group theory of subgroups, I have explained it, that all groups have two subgroups. One is the group itself, and another is identity group, that is identity element and the binary operation. Where the identity group is always normal subgroup of G, because for identity element binary operation, we can write like this, that X equal to the element X will be equal to the identity element. What does that mean? That means X inverse equals to X inverse H, that is X inverse give us the identity element. And if we do any binary operation of identity element with any element, that we'll get the identity element. Therefore H will be equal to E. Okay, therefore H will be equal to E. So that means that the identity group is always a normal subgroup. The identity group is always is the identity element subgroup of a group is always a normal subgroup. It is also asked in the MCQ questions. Okay, it also asked in MCQ questions. Now, what is solvable group? A group having a normal series such that each normal factor is abelian. Now, how can we explain that? We can explain like that. That let G asterisk be a group and G equal to N0. What does that mean? That means where N1 is the normal subgroup of N0, and okay, N1 is the normal subgroup of N0. That is N1 is the subset of N0 and is the normal subgroup of. It means N1 is the subset as well as normal subgroup of N0. Okay, and so on. Then N0 by N1 is called the quotient group. N0 by N1 is called quotient group. This is also a very important deputation, that what is quotient group. Okay, called quotient group, and quotient group is always abelian, and quotient groups are always abelian. This is the property of quotient group. So quotient groups are always abelian. If that happens, then G star is solvable group. Then G star is a solvable group. Then J star is a solvable group. So if G asterisk is abelian, then group G asterisk is always solvable, and solvable groups are always abelian. Why? Because we know this from here. We understand that the quotient group is always abelian, and if this is a quotient group, then it is a solvable group. And what does that mean? That means that, so if G asterisk is abelian, then group G asterisk is, if the group is abelian, then group G is always solvable, because if G is abelian, then G by H is always abelian. Okay. Now what is maximum normal subgroup? First is maximum normal subgroup. Let G asterisk be a group and H asterisk be a normal subgroup. Then H is called maximum normal subgroup if no normal subgroup K asterisk exists such that H is a subset of K and K is a subset of G. So this is called maximum normal subgroup. So I think I have given all the basic definitions that in this video as well as in my previous videos. All together I have given you all the definition, all the basic definition, which is very much required, which are very much required to understand the university question and answers. So please go through these videos, and from the next video related to group theory, all will be about question answers. Okay, no further notes will be given, so all be related to question answers. But before understanding, going through the video of question answers, please go through this video so that you can understand the question answer easily. Okay, as well as whatever textbooks I have referred for group theory, please go through these books after watching these videos. Then you can find the topics very easy to understand. You will find the topics very to understand. So thank you for watching my videos. Please subscribe my channel to get the latest updates. Okay, thank you. See you in next video.